Hello, today in this video we'll be solving CSIR UGC NET 2019 June problem 18 out of the 55 problems in physics. So let's jump into our problem. A AC signal of the type as shown in the figure is applied across a resistance 1 ohm. So this is the voltage graph, voltage versus time, and it is asked the power dissipated across the resistor. Now we know that power is volt times current. So well, this is not that easy in this case, so let's try to solve how we can solve this problem. Okay, now from the graph we can see that the peak to peak voltage is 10 volt, but at t equal to 0 it starts from 3. So basically V naught is 3. That means we can write V as 3 times 5 sine of omega t, right? Because it starts from 0, so this is sine omega t. And given the resistance is 1 ohm, then power dissipated across the resistor P is VI, which is equal to V square by R. Since R is 1, so power will be 3 plus 5 sine omega t square. If we simplify, it will be 9 plus 25 sine square omega t plus 30 sine omega t, right? Now the power, that is the average power, will be average of 9 is 9 plus this will be 25 times half, because the average of sine square theta is half, plus 0. That the average of sine square theta is half and average of sine theta is 0. So we get 9 plus 12.5, which is 21.5 watt. So the correct answer is option D, which is 21.5 watt. I will just repeat again how we solve this problem. We have a voltage versus time curve. We first find the peak to peak voltage, which is 10 volt, and then we try to write in the form of equation. Because it starts from 3, so it is 3 plus 5 sine omega t, and the resistance is 1 ohm. We simply use the power formula and we found the average of the power. The average can be easily calculated, and we use the known relation that sine square theta average is half and the average of sine theta is 0, and we get the power, that is 21.5 watt. So option D is the correct answer. Hope you liked this video. If you learned something new in solving this problem, do give a like and do subscribe to our channel, ring the notification bell. Thanks for watching, and I'll be back in my next video.